Lesson 7.2 is about properties of proportions. Okay, so like we've already learned, a proportion is just an equation that sets two ratios equal to each other. But every part of the two ratios has is named something. The top left and the bottom right in a ratio are called the extremes. So in this case, the A and the D are the extremes. And the other two, the top right and bottom left, are called the means. So it always turns out that the product of the extremes is equal to the product of the means. So in other words, I should use red here. A times D is going to be equal to the product of B times C, or C times B. Okay, and we can use this to solve equations. We cross multiply, and we can have values in these positions and variables and solve algebraically for the value of a variable. Okay, next for some equivalent ways to say the same proportion, A is to B as C is to D. One thing we can do is that equivalent form of this is we can switch vertically. The A and the B can switch as long as the C and the D do. So we could write B over A is equivalent to D over C. And you can see when you cross multiply, you would still be multiplying the A times the D and the B times the C. So this would be equivalent to the original proportion. Okay, so proportions are also true horizontally. I can shift the A and the C as long as I switch the B and the D. So I could have, actually, like so, I could have A is to C as B is to D. And once again, I would still be, when I cross multiply the A times the D and the B times the C. So this would be an equivalent form of the original expression, or the original proportion. And further, I could take this one and shift like so and say C is to A as D is to B. Again, as long as I'm always cross-multiplying A times D and B times C, just like the original proportion, this is another equivalent form. Okay, more on equivalent proportions. If I have, say, 3 or more equal ratios, like A is to B as C is to D as E is to F, those are all fractions that are equal. They all have the same value. We reduce them. Well, then what also must be true is if I add up those numerators, so A plus C plus E, it will be equivalent to, and then I divide by actually B plus D plus F, that the sum of the numerators and the sum of the denominators, when simplified, will still be equal to the original A over B. So let's do an example with numbers of this. Let's say I have some equivalent fractions. So let's start with 1/2 is equivalent to 3/6, which is also equivalent to 5/10. So those are all equal to 1/2. Now this tells me I should be able to add up 1 plus 3 plus 5 in the numerator and divide by the sum of the denominators, 2 plus 6 plus 10, and still have a fraction, a ratio, equal to 1/2. So when I do this, I've got 9 over 8 plus 10, 9 over 18, which is indeed equal to or equivalent to the original A over B, or 1/2. So the bottom line being, I can add the sums, the numerators of equivalent fractions, and divide by the sum of the denominators of those equivalent fractions, and still have an equivalent fraction. Okay, another property of equivalent proportions is that if I take two equivalent ratios, stated as a proportion, they remain equivalent if I take the denominator of each and add it to the numerator of each. So in other words, if A over B is equivalent or equal to C over D, I can take the B, the denominator B, and add it to the numerator on the left, and I can take the denominator D and add it to the numerator of the ratio on the right, and they should still be equivalent. So let's look at with some numbers. Let's start off with, again, two really easy equivalent ratios. 3 over 6 is equivalent to 5 over 10. Those both would simplify to 1/2. Okay, what this says then is that the sum of 3 plus, and I'm going to add the 6 over 6, should be equivalent to 5 plus 10 over 10. So this is 9 over 6, equivalent to 15 over 10. And indeed, 9 over 6 simplifies to 3/2, and so does 15 over 10. So the two ratios remain equivalent. Now, let's think about why this is. What is happening here? Well, what's happening is this. I could take any equation that's true, and I can add 1 to both sides. So if I start with let's start with 3/6 on one side and 5/10 on the other side, and I'm going to add 1 to both sides, then the equation should stay true. We know that from basic algebra. Now, the 1, I'm going to put the left side in the common denominator of sixths. So this would be 3/6 plus 6/6. That's a 1. And on the right side, I'm going to have 5/10. Now, how would I say 1 in 10th? I would call it 10/10. Okay, and then when I'm writing the left side all over the common denominator of 6, I get my 3 plus 6 over 6. And on the right, when I'm writing this both over 10, I get 5 plus 10 over 10. And as you can see, this is exactly what we wrote here when we just applied the property. So that's another form of equivalent proportions. Okay, we're going to be using proportions a lot in this unit when it comes to talking about similar polygons and proportional side lengths of polygons. So we're going to practice just a little bit with solving this. So remember, to solve, we cross multiply. We take the product of the means times the product of the extremes. So we're going to multiply these two together and these two. So I get 3 times the quantity x plus 3 is equal to 2 times the quantity 2x minus 1. And then we could solve easily from there. So if I subtract 3x from both sides, I'll have a 1x on the right. And if I add 2 to both sides, I'll have an 11 on the left. So in this case, x is 11. And if I substitute 11 back in on the left, 11 plus 3 would be a 14 over 2. And on the right, 2 times 11 minus 1, 22 minus 1, would be a 21 over 3. We can see that those are both equal to 7. So it checks in the original equation. Okay, let's solve another one. Cross multiplying. Now we're going to be creating some quadratic equations. First I'm going to have x minus 1 times the quantity 3x minus 2 is equal to x plus 2 times 10. We'll put the 10 out in front. Okay, so when we FOIL this on the left to multiply, we get a 3x squared minus 2x minus 3x, so minus 5x plus 2 is equal to, we'll distribute here, 10x plus 20. So this is a quadratic equation, you can see right here. So I'm going to get it set equal to 0 and try and factor it. So I subtract 10x from both sides. So we'll get 3x squared minus 15x, and I'll subtract 20 from both sides, so we'll have a negative 18. So in order to factor this, first things first, I can see that I have a greatest common factor of 3 in all of those terms. So if I factor that out, I have x squared minus 5x minus 6. Okay, and this is going to be easy to factor. I'm going to have a x minus 6. I have a 6 and a 1. So I need a negative 6 and a positive 1. So solutions are x can be equal to 6 or x can be equal to negative 1. I have to check both my original denominators. A 6 will not make either of these denominators equal to 0, nor will a negative 1. So I'm okay. And I have two solutions. X can be equal to 6 or x can be equal to negative 1. And when checked in the original equation, they will both make it true. And that's it for ratio and proportion.